Hello all, my name is Krish Naik and welcome to my YouTube channel. So guys, I hope first of all, everyone is doing amazingly well in their life. You're learning well. Whoever are interested in data science, I know there are many challenges that may come in between, but definitely continue learning, right? Now, in my channel, I have probably uploaded so many videos regarding end-to-end project implementation, right? We had followed a pipeline of data ingestion to data transformation to model development to model deployment, right? And I also used to say about model monitoring, right? But I never showed you one practical approach, right? Because I was looking for the right kind of open source tools, right? And I love open source tools, guys. And till now, the videos that I have probably uploaded, right, like DAGs Hub or DVC, GitHub Actions, like this in short are like kind of open source tools that help you to perform a lot many things. And that is where MLOps activity comes into existence, right? Specifically with respect to deployment and all. So in this video, now I'm going to focus more on the model monitoring part, right? Probably I've never uploaded a video in my channel about model monitoring, but today I will definitely show you one open source tool, which is basically called as Evidently AI. And I will just give you an example like how you can probably monitor your model, monitor your data, and what all main key terms are there with some good practical examples. But just seeing this practical example, I think you can also easily develop or you can develop a model monitoring pipeline in your specific project. So guys, if you are new to this particular video, please make sure that if you're new to this channel, please make sure that you subscribe the channel, press the bell notification icon. And one more good news, I'm about to reach 800k subscribers. 24th is my birthday. 24th August is my birthday. So I would definitely like you to press subscribe button, make it 8 lakhs at least, 800k. I've been working really hard with respect to my YouTube channel, and many people have also appreciated the content that I have actually put. So yes, if you like this content, please make sure that you share with everyone. Let's target as a gift to me and let's reach 800k subscribers. Okay, so let me go ahead and share my screen over here. So we are basically going to discuss about Evidently AI. Now, what exactly Evidently AI is, as I said, for model monitoring, this will be an amazing handy tool, and it is also an open source tool, right? So over here you can see the open source ML observability platform. And don't worry guys, make sure that you watch this video till the end, because I'm also going to show you some practical implementation which will be super amazing. So here it will evaluate your test and monitor ML models from validation to production, from tabular data to LNP to NLP and LLMs, right? So it covers almost everything. In this video, I'm going to probably talk about one machine learning project itself where I will probably be seeing this. We will see one practical example. And as we go ahead, what we are basically going to do is that we are also going to check for LLM models also. So if you have not seen the tutorials, definitely check out my playlist. I've created videos on OpenAI, LLM models, LangChain, and many more things. So this is the idea about Evidently AI. And if I probably go more, it is always good to have a look onto the documentation. All you need is to rely on ML systems in production, because see, when you're running in the production, right, it is always good to continuously monitor the model. If you are probably getting any kind of wrong results at one specific point of time, it can really lead to a loss of business, right? So here you'll also be able to build reports, you'll be able to test your pipelines, you'll be able to monitor it all, right? Mainly when I talk about model monitoring, it mostly has this 4 important steps with respect to data quality, data drift, model performance. I will explain each and every term. What is data drift? What is model performance? Just to give you an idea about data drift, right? Let's say I've created a model, I've trained with some kind of data, but after some point of time, the distribution of the data may change, the mean of the data may change, the data may look something different, and it can be with respect to time, for a specific product. Let's say if I say a company has come up with some specific product, initially the feedbacks may be bad, later on the feedbacks may become good, right? So something like this kind of data distribution will be there. Even in tabular data, where you have numerical data, there also the data distribution may change. So Evidently AI actually helps you to track this using data drift techniques. We'll see that model performance also, it will be able to see, and each and every examples is also given over here. But just to show you, Today, I will be taking one machine learning problem statement, which is basically called as bicycle demand monitoring. And if you don't know, this problem statement obviously is also, the data set is probably taken from Kaggle itself. We'll try to see, and we'll see that how things are, each and every line of code I will execute in front of you, and I'll try to explain it. Just by seeing this, the prerequisite is that obviously you need to know machine learning, some amount of stats, and then you'll be also able to understand it. So let's go ahead and let's have a look. So guys, now let's go ahead and see step by step. So to begin with, what we need to do is that we need to import this evidently. And if it is not getting imported, what we'll do a pip install. Okay. So evidently is also available in PyPy. So if you just write pip install evidently, you will be able to get it. So I will just go ahead and execute this. It will probably take some time with respect to the installation. So here you can probably see the installation is basically happening. And then we can go ahead and do the importing of the evidently itself. So initially, we definitely require this library. This is the entire thing. You can also join the Discord. You can ask questions because there are many people with respect to this particular open source tool, right? You should definitely know how to use it, right? And I am really focusing on a lot of open source tools as we go ahead. I've discussed about DVC, as I said, DAGs Hub, and it is quite amazing, right? So here you can basically see that we have imported, we have installed it. Now the next thing that we are probably going to do, okay, this is super important, okay. We are importing pandas numpy request zip file. There is a reason why we are doing zip file. I'll tell you, because I am going to extract a zip file from a different location and then probably download the data set. In evidently, we'll specifically use something called as column mapping, okay. Why this is used, I will just let you know in some time. And then we will also be importing reports in evidently.reports, which will be responsible in creating the entire reports itself. And there are also some metrics in evidently, which is basically data drift present, target drift present, and regression present. Okay. So each and everything has some importance, right? This is specifically to understand the data drift. This is specifically to understand whether the target variable has changed or not. And this is specifically for a regression problem statement. What are the various parameters that we may have? Like performance metrics, we may have like mean absolute error, root mean squared error. So based on that, if that is changing or is impacting the entire model, that also will be able to see it. So these are some of the libraries that we are going to import it. So here I'm going to just import it over here. So it will take some time. So the importing is done. Okay. Now, if you don't know about this problem statement, guys, bicycle demand data, right? So here is the Kaggle data set, Kaggle link. So here you'll be able to see that I will go to Kaggle. Okay. What is the problem statement? Okay. You are provided with hourly rental data spanning 2 years, right? Of how many people ordered a bike or ordered a bicycle. Sorry. For this competition, the training set is comprised of 19 days. And the test data is 20 end of the data. You must predict the total count of the bikes rented during each hour. So at every hour, you really need to find out like what is the total count of the bike. So this is the problem statement. So now let's go ahead and first of all do step by step. Initially, we will be reading the data set. For reading the data set, we are going to use this specific URL where that data set is available in the form of zip file. And we can basically use request.get. So once we get that entire content, we can probably use zip file, io.bytes content as arc. And this is what we are specifically doing. We are extracting the zip file and reading the CSV file with some of the features like header is equal to 0, separator, parse dates, index columns, which are specifically required to see the raw data. Okay. Now, once I execute this from the zip file, we are going to extract it. And these are something basic things. With respect to reading CSV file, we'll be able to see it. Okay. Now, over here, one more step we are specifically doing. We are combining the row name with respect to the hours, and the axis is equal to 1. Let's go ahead and see with respect to the raw data head. So here is my entire raw data. So here you can see that I have all these particular features, or what you can do if you don't want to do all these things also, directly download the CSV file, right? Download the CSV file and use it over here. Okay. These are some of the additional things that we really need to do to extract that particular zip file and all, which will also give you an idea about it. Okay. So I have actually taken this code from the documentation of Evidently AI. Now, Here we will probably start with something called as regression model. Now in regression model, we are going to create some variables. Okay, now these variables will play a very important role. Now I know what is my output feature over here. My output feature is CNT. Okay, so what I will do, my target variable I will create. I will note down that variable name over here. I will also create a prediction column, right? To just see like what prediction my model will be doing. So that name of the column will be something like prediction. Then I'm also going to divide all my features into numerical and categorical features. You'll understand this, guys, why I'm specifically doing this, because evidently AI, whenever you're doing the column mapping, this is the first thing that is specifically required. What is the target variable? What is your prediction? What is your numerical features? What is your categorical feature? Each and everything is specifically required. So that is the reason we are trying to define in this specific way. So here you can basically see target, prediction, numerical feature, categorical feature. Okay. So all this, it is not necessary that you always need to write the name like this. It can be your variable name itself, but always try to make this division like this. Okay. So one is the target variable, prediction variable, numerical feature, and categorical feature. Now, once we go ahead and execute this, let's go ahead and execute it over here. Now, the next thing, as you know, right, in this particular data set, you will be finding hourly basis data, right? Everything you'll be finding over here, hourly basis, right? Now, based on this hour, the count of the demand of the bicycle may change, right? So, if I probably consider this, I want to probably check data drift or model drift, right? I always need to make sure that, first of all, I train my model on some data, and on the upcoming data, I probably check how my model is basically performing, right? So that is what I'm actually going to do over here also. So if I go down over here, you can basically see I've created a reference data. I will tell you why this specific reference data is there. I'm taking from 2011-1-1, that is January 1st, from morning 12 to night to, let's say, to 28th Jan 11 o'clock. I have taken this all data as my reference data. So probably I may use this reference data for training my model, right? And then this current data will probably be used for the testing purpose. Let's say for right now, we will use this data for testing purpose so that we will be able to test the model. So here I'm going to probably define this so that I will be getting my reference head. You'll be able to see my data will probably start from this date and it will end till this particular date, right? 28th. Now this is done. The next step, I hope everybody knows about random forest regressor. We are going to apply random forest regressor with some estimators and some random state. I'm going to just create this particular model. And then I'm going to do the fit on this particular reference data where I use both numerical and categorical feature. And this is my training data, right? Training, like it's just like X train, and this is just like my Y train, right? This is my output feature. These are all my independent feature. These are all my dependent feature. So once I execute this, you'll be able to see that random forest regressor model is basically created, right? So I hope till here you have the exact idea what we are specifically doing. Now, after I probably create the model, what I'm actually going to do is that I'm going to do the prediction for this specific reference data. So prediction for this reference data, just like my X train, okay? And here, for this, I will be using regressor.predict, which will basically do the prediction part, okay? Now, similarly for the new data, I can also do regressor.predict on my current data, which will include both numerical and categorical features. So through this, I will basically be getting my prediction, right? So this is the prediction for the ref prediction, current prediction, right? So this is very much good. Till here, we are able to get all the predictions also. So guys, in the next step, what I will do, the prediction column that we have actually created, I will try to store all those predictions over here. That's it. So here is all my predictions. So I'm basically creating a new feature within the name of prediction on both reference and current. Okay. So this is fine. Now this is where your model performance will be checked, like how well your model is basically doing. Okay. To start with, the column mapping that we have imported on the top, right? If you remember, we had actually imported column mapping over here, right? Now this is where you'll understand the importance of column mapping. So in column mapping, you first of all create a target variable and you'll assign the target. Then in column mapping, you basically create a prediction variable. So this dot target dot prediction is a variable inside column mapping itself, right? So here you're basically going to assign to prediction. Then there is one more feature which is called as numerical feature, which will assign to the entire numerical feature. And then column mapping dot categorical feature, you'll entirely assign to the categorical feature, right? So this is what you initially do. Now I have mapped all the features over there. Now it's time we use those reports, that reports library that we have actually imported, which was present inside Vidently, right? Vidently.report, import reports. We will be using this report and then we will be keeping this metrics as regression present. Since this is a regression problem statement, if it was a classification problem statement, we could have written classification present, right? So this is where we have basically created this particular metrics, okay? And then we are just going to run, where I'm going to assign the current data. See, current data basically means what my model is currently trained on. That will basically be my reference data, right? And my reference data, I can assign it to current prediction also, current data also, right? To my current data itself. But right now I'm not assigning anything to just see how my model performance is there, right? And this column mapping feature will get assigned to the same column mapping variable that I have. So once I execute this, see guys, it is very much simple. If you are probably following step by step like how I've explained, you'll be able to understand it very much easily. Now, if I do regression performance dot show, here you will be able to see, I will be able to get the entire report itself. Now, this is what is the report we are looking at, right? Right now, we are not comparing with any model, right? Right now, we are not comparing with any model because I've just trained my model with respect to reference. And I'm just trying to see the model performance. Now, how do I see my model performance? So the first feature with respect to model performance and the target is CNT. I can over here see that the current model quality is minus 0.03 ME. Okay. So this is very, very good because it is just minus 0.03. Now, if I talk about MAE 4.1, MAPE 16.13. If I see with respect to predicted and actual, right now, see, this is what is my predicted versus actual reference. Okay, this is how my data looks like, and this is basically the current data. I'm not comparing it with anyone right now because later on we'll try to compare the next 7 days data or next 1 day data that I do, and I do the prediction, then I will try to compare. Okay, so this is the second one. Now see, predicted versus actual in time. So see, this red one is basically the predicted one, and actual is the actual data, and it is very much near to each other. So that basically means my model is very, very good with respect to what we have actually trained right now. So that basically means my model is not degrading right now. Whenever we get a new data at that time, again, we'll see this graph and we'll see that how it is performing. Okay. So here you can see, basically see that, okay, it looks really, really good. My data is over here and it looks absolutely fine. Now, if I go and see error predicted minus actual. So here also you'll be able to see this red line is basically my difference between the predicted and actual. It is very much near to this, within this -5 to +5 standard deviation. That basically means within this range, which is again very, very good. -5 to +5 in a regression problem statement, it is absolutely good. Now, if I go ahead and see with respect to absolute percentage error, then again it is very much less. Within the zeros line also, you can actually see over here with respect to the red line. Okay, this is good. Error distribution also, it ranges between -20 to +20. It is symmetrical, almost symmetrical. So this is also a good indication with respect to this. And there is something called as error normality. In the error normality, you'll be able to see all the data points, right? It should be falling on this specific line. And if you have probably seen my video, this is basically, we have created theoretical quantiles to just understand whether my errors follows a normal distribution or not. So if it is falling on this particular line, it basically says that yes, it is following a normal distribution. Now, I hope you are able to understand, guys, why I really focus on theoretical concepts, right? We have learned statistics theory, we have learned machine learning theories, we have learned feature engineering theories, and all these things are super important when we discuss the concepts like this. And obviously through this, we are actually monitoring the entire model. Now, this is fine. Then the error bias is also very, very less. The majority with respect to all the prediction, only this much difference is there. Underestimation basically means how much I can underestimate. So if I say the number of bikes ordered at a specific time, let's say it's 20, I can underestimate to 4. That basically means 20 minus 16, right? 4. 4 can be my lower point of prediction in those scenario. In the overestimation, if it requires 20, my model can predict up to 34. Okay, which is obviously the error is basically there. So that is what underestimation and overestimation is done. Predicted versus actual group. This is how my underestimation and overestimation looks like, if you probably see in the graph. Okay. So guys, the next step, what you can probably do is that you can also save this particular reports in a kind of HTML file. For that, you'll have this specific command. Now, going forward in the week 1, let's say, now in the week 1, what will happen? The data will obviously change. Now, when we do that specific performance check on that data, can we find out some kind of model drift, or can we find out some kind of data drift, or can we check how the model performance will be, right? And that is what we are basically going to do. So again, I'm going to create this metrics for this particular report. And now I will just do this regression performance run on the current data from this time to this time. That basically means from my next 1 week from the reference data or the current data that I have, right? Then the reference data will be the previous data that I've trained my model on. That is basically the reference. And all the column mapping will be same, whatever reference predictions that I specifically have. So what I'm actually doing, I'm taking the next week data, and then I'm comparing it to my previous model, which is my reference model. And I'll try to see that how my performance will look like. So if I do this and probably dot show, now you'll be able to see a very good defined metrics where you will be able to compare each and everything. Now this is where it is so much handy, guys. Trust me, it is very, very handy. So here, the regression model performance target count. Now see how beautifully I get this entire report. Now the current model that I have, which is through the reference data, the current model, which is basically trained with the new data itself, right? So new data I've actually given over here, right? The current data is this one, right? With respect to the current model quality, that is based on the new data. This is what is the ME, MAE, and MAPE. And if I probably see my reference model, right? There you are able to see minus 0.03, 4.1, 16.13, right? Now, if you probably compare both these values, yes, there is a slight difference. Before it was minus 0.03, now it is minus 6.14, 13.38, 4.1, 40.8, 16.13, right? Now, obviously you can see that there is definitely some more difference with respect to the model quality, right? Now, let's see some more things with respect to predicted versus actual, right? This is right now my current model. This is how my counter plot looks like, right? With respect to predicted and actual value, if I probably map it and if I plot it. If I see with respect to my previous model that was trained on the previous data, this is how it looks like. This is also almost same, but here you can see that this width has got decreased, right? This width has actually got decreased. So some information you are able to get saying that model has really changed a little bit, okay? Then let's go with respect to predicted versus actual in time, okay? So right now, this is currently with the new data, how my predictions look like with respect to the actual. So the black line that you'll be able to see is actual. The predicted line is basically the red line. So obviously there is a lot of difference over here, right? I'll not say with respect to all these points, but here one point is having a lot of difference. See over here, right? So definitely the difference between actual and predicted are also changing. This was my previous one, right? It was very much near to each other, right? So obviously you can see that the model is degrading a little bit. So what we should do in the time, we should combine the previous data along with this particular data and then retrain our model. This is basically giving you a indication that you have to probably train your model by, right? Because here now your prediction is completely changing, right? And it is really having a lot of difference. With most of the points it is fine, but with some points it is having a huge difference. And this is just an indication saying that the model performance is degrading now, okay? Now, if I probably see the error, that is predicted minus actual. Before you could see it was ranging only between this to this, but now it is ranging between 40 to minus 80. So this is what you can see with respect to the difference. And this is the same point that you can probably see over here. This is the same difference, right? That is the error between this. You can basically say the error. The error is quite huge. And this also you can probably check. In my previous model, the error was less. Right now, the error is more. So is it good that I probably take this weak data and again train it in my model? This is basically giving an indication, and you should definitely do it, right? Now with respect to the absolute percentage error, again, there is a huge change when compared to this. Error distribution, before it was ranging between -20 to +20, but now here you can see -50 to +50. There are some points, but the current model shows a lot of error distribution, right? It has been increased. Error normality, this was my previous one. Most of the points are falling in this particular line, just to show that my error normality, the errors follows a normal distribution. But in this case, you can see it has moved from this particular path, right? Now, if I probably go ahead and see more, right, how things will basically happen. Now, error bias table, here you can see current mean, then predicted versus actual, all these things are there. And obviously, it will give you a very good amount of understanding. Now, this is also very important. Underestimation, right? Before it was -16, now it is -64. Overestimation, before it is +14, now it is +28, right? All these things are basically there. Now, similarly, what I will do, I will probably take the target drift and again create a report. This was with respect to the model performance, right? By taking the week 1 data. But if you remember, we had also imported the target drift library package to just see, okay, now in this scenario, you may be thinking, Krish, did only the feature changes or did my target feature also changed? Because whatever new data that I'm getting, the original target feature also is getting changed. It may be getting changed, right? So for that, what you will do? You will probably do something called as target drift. Now for this target drift, you will be taking the reports, metrics, target drift preset, and now you will be setting your current data to that specific data and your reference data to the previous one. Now let's see whether my target variable has changed or not. And that is possible with the help of target drift over here. Okay. So now if you probably go and see drift in the column prediction, whether there is any target drift or not. Okay. Let's see drift in column count. Okay. That basically means I'm just checking that is my target variable changed. So this is what is the current it looks like. This is the value that we have. Okay. Now here you can basically see the correlation, right? Current and reference. So here everything almost looks fine. Only with this particular data on the weekdays, it is getting changed. The correlation is inversed. On all the other data, the correlation is almost positive, right? If you probably see with respect to Spearman, Kendall, right? All these things, it looks good, right? So this is basically giving an indication that the target variable did not change much, right? What about data drift? See how my data drift looks like. It was basically giving with respect to the current, and this is with respect to the prediction, right? This is how my current data looks like. If I probably see data distribution, right? Current and reference, right? So current over here, you can basically see the count is very, very less, right? And this is how your data looks like. Correlation for column prediction. You can also see how the prediction correlation is. It also looks almost same. Spearman, Kendall, already everything looks almost same. So I feel that target drift is not there. Only some amount of changes are there with respect to that. But definitely your data is getting changed, right? Then again, you can probably do it for the week 2 data, week 3 data, and probably keep on changing. Let's say that I tried for week 3 data. Now here, you will be able to see now your model will be degrading more and more. And this usually happens with this kind of data itself. Now definitely it will be degrading a lot. Now see the degradation that you will be able to see. Okay. Current model quality is -22. See, it has increased now. Here 24, here 41, right? It is increased, right? Current and this and this. Again, this counter plot looks completely different with respect to this, right? Here, your actual and predicted, there's a huge difference. Before it used to look like this, right? Error minus prediction, right? Prediction minus actual, again, a huge difference. So definitely this is giving you an indication by you really need to train your model now. See, this error distribution, it has gone to, I don't know how much minus it is over here. It is completely left skewed. Here, my value was between -20 to +20. Error normality, obviously it is nowhere falling in this specific line. So error normality is also there. And this bias table, see, -111. So if my model is basically, if let's say for a current time, 20 is required, it is predicting minus so many minus, right? So this is the time that you really need to start training your model, right? And again, you can also check with respect to target drift and all. Data drift is also an option if you probably want to check, right? So this is what is the power, guys. And by this, you get an idea, right? Whether your model requires training or not, right? So I hope you like this particular video. I will share you this entire notebook. Just execute line by line. If you have just executed, or if you just know how to train a model um, in a Jupyter notebook, you will be able to understand it. So guys, yes, this was it from my side. I hope you like this particular video. I will see you all in the next video. Have a great day ahead. Thank you, one all. Take care. Bye-bye.